reading a bit off the screen, and I'll try and go sideways and keep my back to these invisible people rather than you guys, but apologies. So this is a talk that I put together at reasonably late notice because it wasn't clear if I was going to be able to come to linux.conf. It's called a GStreamer talk, a name that I canvassed with some friends of mine who told me that it was very poetic, then proceeded to tell me that it was so GStreamer, much talk. Wow. Nevertheless, I'm sticking with the title. This is a talk where I will be talking a bit about what's been going on in the GStreamer project in the last couple of years, and then rambling, probably mixed up a little bit about me. My name is Jan Schmidt. I am a co-founder of a reasonably new company called Centricular. I'm a GStreamer maintainer. Actually, there's more about that on the next slide. So let's just, I live here. This is more useful when I'm overseas, but people here already probably know I'm from Australia. Albury Wodonga is where I live on the New South Wales-Victoria border. And the details of where you can find me. So I've been a GStreamer developer since 2003. It was full-time job for me from 2004 till 2007, working for Fluendo in Barcelona. And then part-time from 2007 to 2009 when I worked for Sun in Ireland, and then hardly anything at all for a couple of years after we got bought by Oracle, and my open source activities were somewhat curtailed. But happily, in July last year, I was laid off when they shut down our product. And so that's freed me up again. I've joined forces with two other GStreamer maintainers, and when we formed the company Centricular, we're now full-time doing GStreamer and open source multimedia consulting work. And when we're not doing that, I like to live on our bit of land in Albury Wodonga, and we grow a bunch of our own food, and there's some of our own food. So what is GStreamer? Probably most people already know, but it's good to always do the quick rundown. GStreamer is a graph-based multimedia processing framework where you can connect components together to create a flow that will process video, audio, or not even necessarily video and audio. It's a general graph processing expression language. So people have done things that are not at all multimedia related using GStreamer, so like scientific instrument capture and analysis work. It is a platform for building functional blocks that you can use for doing multimedia tasks, and most often that's achieved by wrapping other libraries that implement low-level details, such as the libav fork of the FFmpeg project, or various video and audio decoders, or multimedia handling libs. It has good integration with other frameworks like WebKit, Clutter, the platform, the multimedia processing that various platforms like Windows, OS X or Android make available. We wrap those up and then create a cross-platform layer that you can use. And it provides a set of layered APIs from low-level, I need to move these frames of video and access the pixels, to high-level, I want to run 3 functions and load any file from anywhere in the world and put it on a screen, kind of things. So the biggest, I guess, thing that has happened for us in the last couple of years is releasing the GStreamer 1.0 framework. So that was in September 2012. And I guess why is that important? Well, so GStreamer started in 1999 and as a research project from University of Oregon, and built from there. Over the next few years, we went through a few revisions, 0.2, 4, 0.6 was where I came in, And 0.6 was about the point where GStreamer could reliably play audio files, and was still a bit flaky at doing that. We kept going. 0.8 was about the point where we could play audio really reliably and could do some video things. And then 2004, 2005, when a bunch of us were employed by Fluendo to build the Flumotion streaming platform and turn GStreamer into a really reliable piece of software, that was when we worked up to 0.10. And 0.10 was released in December 2005 as a commercially viable piece of software with a guarantee that companies who wanted to build things around GStreamer could rely on, which was that our APIs would be stable for the entire 0.10 series, which was a bit bold at the time because we were not even sure we liked those APIs. But you commit to them and then you stick with them, and then as it turns out, we managed to make those work and keep API backwards compatibility all the way through to 2012. At which point we were all a bit tired of the straitjacket, well, the pieces of the commitment that were itched, the bits of 0.10 that we didn't like. And it was good to finally be able to cut those ties and do a new version where we could break API, fix the nits that were bugging us. So we did that and released it in 2012. GNOME switched from using GStreamer 0.10 as the underlying media framework to relying on 1.0 in GNOME 3.6. So that was a year ago now, and overall they've been very happy with that. We've been very happy with what the APIs provided. And so here are a few of the things that we really enjoyed changing as we went from 0.10 to 1.0. So the core of GStreamer changed a fair bit. Most of the work was in the core. And it was a good fix for a bunch of conceptual problems in 0.10, such as the conflation of allocating buffers versus negotiating what format buffers should be. Seemed like a good idea in 0.10, but really that caused a lot of hassle. So in 1.0 we split this idea of figuring out what format you're going to pass between each other and actually allocating the buffers that you're going to pass those around. So they're two separate things, which is good because now we can more easily do operations like switching format on the fly while you're passing buffers in the old format, and then you negotiate the new format in advance, and then you get to it half a second later and start passing things in a different sample rate, for example. And also that separation of allocation into a whole separate step gave us a whole conceptual framework for doing some nice things like modeling abstract pieces of memory that you can't directly access from the CPU. Instead of just passing around malloc to data, now you can pass around a handle to a hardware decoder's representation of a buffer. And that frees us up to do things like zero-copy decoding straight out of a hardware decoder and passing a handle across to a GPU for putting onto the screen or doing other GPU operations without having to pull pixels back. So that's a huge efficiency gain and pretty imperative on a lot of low-level embedded hardware. What else? We've got new platform support, Android and iOS. GStreamer now supports with 1.0. So people are now actively porting and building apps onto Android without having to adapt API at all or even care that they're using Android multimedia APIs. So that's been a good boon. I've got a demo of that maybe later, depending on how I go for time. And a host of new hardware platforms that have opened up as people have started switching over to 1.0. We've got new features, like I've said, like the ability to represent abstract buffers. We've got new things like representations of 3D video formats and buffer layouts, proper representation of interlacing so that we can do deinterlacing more cleanly. one really huge nit in 0.10 that we just couldn't fix without breaking API and ABI. The ability to represent a DTS and a PTS timestamp on a piece of media as two separate things. Something really fundamental that we missed before we froze the API and then had to live with and hack around for 7 years. So that was rewarding. We started moving more functionality down into base classes so that elements can stop reproducing over and over the same fundamental behavior. So all our video decoders are now based on a single video decoder base class that implements the variety of functions that different video decoders and encoders need. Thousands and thousands of bugs were fixed along the way, like literally thousands of bug reports have been closed along the way. And we switched to a whole new versioning scheme at 1.0. So whereas before we were 0.6, 0.8, 0.10 were our stable, and 0.3, 5, 7, and 9 were our unstable. Now we've swapped to the same versioning scheme as GNOME and as what the kernel used to use, where 1 dot even numbers for stable releases, 1 dot odd numbers for unstable releases. So the whole versioning schemes shifted up for, one major, and that means that the entire 1 dot anything GStreamer series will be backwards compatible with 1.0, and the next API and ABI break will be GStreamer 2.0 somewhere down the road. So again, that's an important guarantee that hardware vendors want when they start wrapping up GStreamer elements, is that those elements for wrapping their hardware are still going to be useful a few versions down the track, that they're not going to have to port and support a whole bunch of APIs and ABIs each time we release a new tarball. So that's the big overview. What's the last couple of years? What specifically and more recently? Well, in that 2 years since 1.0, we've had loads of things happen, lots and lots of activity. It's a bit hard to see the lots of activity here. That's the pine tree in our backyard, covered in lots of activity, the bee swarm that came over the fence from our neighbour's house. I like the picture, it's a good metaphor for loads of activity, loads of bugs. And what do you do when you get loads of bugs? Well, you put them in a hive. That's me. It's my neighbour Terry. He likes to keep honey. Keep bees and makes honey, so he has loaned us a few hives. This summer we had 3 swarms come over his fence, so we now have 3 beehives and are learning how to keep bees. So a few random highlights of things that have been going on. The GST plugins GL module is our integration with OpenGL functionality, and in 0.10 we really struggled to get that to perform adequately or do anything other than be a real toy, because it was very hard to map the OpenGL, especially Mesa GL requires all your operations to be done from a single thread without context binding every time. GStreamer is heavily multi-threaded, and you can't really predict what thread particular operations are going to happen from, and that didn't mesh well with OpenGL at all. So in 0.10, OpenGL was a bit of a toy. You could decode video frames, you could upload them to the GPU, and you could do things, but in 1.0, because we've got this buffer model abstraction and memory abstraction, it becomes a lot more powerful that GST plugins GL can now pass around handles to things and simplifies the threading, simplifies the allocations, and it now works a lot better where you can use GST plugins GL or the Eggle sync on your Raspberry Pi in conjunction with our OpenMax module to do zero copy decoding out of the hardware and pass it straight onto the screen for processing. We've got the GST streaming server that David Schlief originally put together, and it's a project he started because he has a company called Entropy Wave in San Francisco that puts together encode and like ingest and transcode streaming boxes. So he put together the streaming server, which is a media stream management and delivery service, and that's being used by RDO in the US now as part of their video streaming service that's like Netflix and Spotify stuff. So that's kind of cool. It's very high level. It doesn't care about particular APIs. It's just about, but it knows how to put together GStreamer pipelines to transcode video into formats and stash them away and respond to requests and then deliver via HTTP or RTSP or whatever the client is set up to receive. And builds on top of the GST RTSP server that, again, if I get time, I might talk a bit more about, but effectively it's a GStreamer component that makes it super simple to set up an RTSP feed wrapping any GStreamer pipeline that you can set up. So you can very quickly set up an RTSP service that streams the camera on your laptop, or that grabs a remote HTTP stream and then reflects it as an RTSP stream. Dash and HLS, that some people may or may not have seen those acronyms. They're about adaptive streaming and reaching clients across the web, where you're switching frame rates, switching bit rates and stream qualities on the fly to adaptively deliver. So we've got new implementations of those that we couldn't do in 0.10. That's new functionality. There have been improvements in our DVB and MPEG-TS stack that again come out of the API additions and things that we wanted to do in 0.10 that were API-wise awkward. We've now been able to fix those. Kerberos and the GStreamer SDK. The GStreamer SDK is another project designed to make it easier to get involved in using GStreamer in your project. So that was Fluendo and Collabora, two other GStreamer companies, banded together to put together the GStreamer SDK, and Kerberos is a build system that grew out of that. And what it gives us is that you can nowadays go to the GStreamer website and you can download the GStreamer SDK as a Windows installer or as tarballs, and you can download a binary module for whatever your target platform is and just get coding without having to, on Linux it was always easy. GStreamer is packaged up in your distribution. You could install it and start coding things, but it was always a bit more awkward to get, say, Windows binaries so that you could start developing Windows GStreamer apps. Now it's easy. You get a setup.exe that you can install and fire away in Visual Studio straight away, or download the Android SDK and you can start running through the tutorials and rolling out APK files that use GStreamer to do some multimedia ups. Much improved documentation, and our QA has gotten a bit more back on track now that we've revived our continuous integration build bot. So we now have our IRC bot back that tells us the instant that someone breaks our build, which is still a little bit annoying because some of our tests are a bit racy, so sometimes we get spurious failures and announcements on IRC, but that is good incentive to go and fix our racy tests. VAPI and VDPAU acceleration APIs. I should also have OpenMax and in there. Those are all now becoming nice and usable, especially OpenMax and VA API as good modules for accessing hardware decode and encode functionality on whatever your platform is, especially on embedded. Support for interesting new formats like DALA and VP9. DALA in particular is interesting. I think there was a talk I would have really liked to see in this mini-conf that Greg Maxwell gave at the GStreamer conference in October, and people may have seen blog posts from Monty about the DALA video codec that Mozilla and Red Hat have been working on, and it aims to be H.265 or better quality video, sidestepping all of the patents that are involved in that by trying a whole bunch of new novel techniques. And so far they look really well on target to go and beat the pants off VP8, VP9 and H.265. The same as they did when they did the Opus audio codec and came out with an audio codec that is world first class and completely open and unencumbered. And bugs, always bugs to fix. There's always lots of bug fixing activity. So me personally, what have I been working on? I am the maintainer of our DVD playback functionality. So lately that's going back and fixing a few problems from the initial port of DVD to 1.0. DVD is, for me at least, the most complex playback situation that GStreamer has to handle. The interactivity requirements and the specific timing things that the spec require are quite difficult to achieve in a generally abstracted multimedia framework. So I would say that I've been working on DVD playback since 2004, and I've written DVD playback things from scratch for GStreamer, I think 3 or 4 times now. And it's, you know, it's finally at the point where you can put a random DVD in and expect it to play, and has been for quite a while now. And I think most people don't see the holes anymore, but I know they're there. Our network clock, that I'm also going to talk about in a minute. That's kind of cool functionality. I won't say more. Working generally on the GStreamer core, fixing bugs, and my Arena media player project that sits on top of GStreamer. And wait.
What is Arena?
Interesting, you should ask. I have prepared some slides about that. But let's first rewind. Last year, linux.conf 2013, I was due to give a talk. And then I had to pull out at the last minute because this happened. My son was due in February and arrived in December, and was still in the hospital when LinuxCon rolled around last year. She was tiny. So that was a bit fraught and stopped me from attending last year. But he's okay now. He makes good messes. But that meant no LinuxCon 2013 for me. You come back 1 year. So here I am. So last year I was going to talk about Arena. And Arena starts with my cousin Levi. In late 2012, I went and visited him down in Melbourne. And he showed me a system that he's got that probably most people here have heard of, and certainly since then it's become a lot more common, but I hadn't heard of it really at the time. So he's got a Sonos installed at his place that is expensive hi-fi equipment that lets you put wireless Sonos boxes around your house, and they collectively form their own wireless network, and you talk to it from your phone, and when you press play, your speakers all go play, and you can say play in the bedroom please, play in the lounge room, and they all sound like one house-wide stereo system, and it's all very neat. And I thought, that doesn't sound that hard. So Arena was born, and it is a distributed media player with a very simple idea that you share a clock between all of the devices in your playback graph, and you make sure they all have access to some common piece of media, and you have a command and control system for hanging the whole thing together. And it's based on the GStreamer network clock that I mentioned earlier, which is our implementation of something that's a bit like NTP and gives you a common reference, a local estimation of a clock that's running on a remote machine, whatever clock that might be. You might share the audio clock from a sound card or the system clock, and export it over the network so that you can use it for doing things on another machine elsewhere. This demo is not going to work well if that network keeps doing that. And then the other pieces of Arena is a HTTP file server and a web server that ships JSON snippets back and forth for the command and control. It's got an amazing Ajaxy interface that I strung together back then and have not changed since. That's the whole thing. It's brilliant. Engineers interface. Since last year we've had an Android client added that's kind of fun. So now my phone can participate in the graph, and it effectively takes a playlist of files and it gives you a random shuffle with a next button, and no ability to choose which song you want to listen to next other than skipping the one. But it can play actually any URI that you give it, so you can just tell it to play any HTTP URI and have that pop up on every screen, so you can play a movie on the TV but mute the TV but have your laptop have the sound on it, for example, which is useful at 2 o'clock in the morning when I've just finished hacking on Arena and my wife's asleep. I've got this is an underway project with an old stereo system and a Beagle board slapped into it, so that's becoming a separate standalone node for this idea, that it'll just run an Arena client and slave itself to the things. So I'll have the stereo in the corner that I can play this music from. Oh, and these things, I met a guy in Albury who runs this company called Tagster, and they sell little NFC dot stickers that are fun. So he gave me some samples of those, and with a little app on my phone I can program them so that when I drop the phone on it, it hits any URL or runs an Android app with an intent. In my case, I've just got it going and hitting the URL that plays or pauses my music, so I can drop my phone on the desk on the play button and my music goes. So yeah, the internals of that. The network clock is the main piece, right? You go, and it's pretty simple. You've got a provider on the server, which is given some clock, and then on each client you have the net client clock component, and they just do ping pong. It's every now and then the client sends across a request, and it gets back a pong that says the time is now whatever, and it uses that information plus when it sent it and when it received it to try and guess at what point was the time that when the server answered. We get a bunch of those observations, do it about every 100 milliseconds to start, keep 32 samples, so it's about 3 seconds. Collect a few samples at the start and then run a linear regression on them, and then estimate the drift rate of the clock and bring them into phase. And it works pretty well. So you can't see the remote time there over the, I think that was milliseconds, so it's 140 seconds, or a bit over 2 minutes worth of slaving. It's pretty good, but there is some devils in the details. So that's error in seconds of up to 300 milliseconds. I think that the clock drifts out there, which is not that good if you want to try and keep audio synced to each other. So there's a bit more work to do, and since then I have done a bit more work. And the biggest problem with that is about this on Wi-Fi, and I've discovered my Wi-Fi at home sometimes stalls when you send the ping. Sometimes it'll be like a full 700 milliseconds before it comes back, and it's kind of hard to estimate and keep clocks synced to within a millisecond or two when your response times have that much window on them. So a bit of simple filtering has really cut down a lot of that. And anyway, there's a bit more about that later. So yeah, our startup time just says the clock is 0 for a bit of a fraction at the start, and then we start following. I don't remember what I meant when I wrote these. Wi-Fi versus wired, that was the important thing I discovered, that the GStreamer network clock, when we first wrote it in 2005 for Flamotion, was all about servers that were running on the same wired segment with really low latency, and the clock accuracy and stability was really high, and it doesn't work that well over Wi-Fi.
Is this for machines that don't have a clock at all?
No, this is for the fact that even when you have a clock in every machine, the crystals are not perfectly aligned. You have parts per million of drift, and over the course of tracking the same clock for an hour or so, things drift, right? So if you want to seamlessly strap songs together and you're playing samples out an audio card over here and samples out an audio card over there. Over time, they will have played a different number of samples and they'll drift out of sync. And it starts to sound like an echo. It's the same thing that John was saying in his talk about recording on different machines. You have crystals that are fairly accurate, but they are not perfectly accurate. Then, otherwise we'd have no point, there'd be no need for atomic clocks if...
So past million is enough to cause that problem.
Yep. And sometimes it's worse. I've seen systems where maybe the